Dear participants, today again we are going to enjoy the session of Dr. B. Mahalingam sir. On behalf of all the collaborating institutions, the Department of Geography and the Internal Quality Assurance Cell of our college, I welcome Dr. Mahalingam sir and you all, and I request Dr. Mahalingam sir kindly proceed ahead. Today he is going to talk about accuracy assessment. Also in further he will focus on levels of classification. Over to Dr. Malingam sir.
Thank
Sir
you so much,
please,
Dr. Sir.
please.
Thank you so much. So in today's class, we are going to discuss about how to perform accuracy assessment and how to find out what percentage of accuracy is our classified image. So why it is necessary? It is necessary to evaluate the classification done by us as well as how much it is reliable to implement any kind of activities based on our result. For example, when you produce your land use land cover result with 90% accuracy, which means with the true ground, your result 90% reliable. So when we have more accurate with the true well, more reliable information we are providing, right? For example, when you want to find out how many hectares of agriculture land in a district, and if you produce with the accuracy of 98, then you are giving the information to the users, the exact information of the land which is in that particular district covered by agriculture. So if you give with the 50 percentage, then if anybody wants to implement any kind of agriculture activity scheme, then that will not match with the real world, then it will end up with kind of problem. So that's why when we perform land use land cover, we get the result. Sometime when you get the result, your result may not be correct. So we do kind of correction which is called as a recoding. So after recoding it, like mostly we correct as much as possible from our hand, our result. Once it is finished, then we will collect some samples to compare with the real world to identify how much percentage of accuracy is our classification. To prove this classification, we use a statistical method called kappa coefficient as well as error matrix. So these things we are going to discuss today. I will share my screen. I hope you can see my screen. Am I right? Right. So here I have the satellite imagery, which is I downloaded from Copernicus program Sentinel-2A data, which is having the spatial resolution of 10 meters. Cell size is 10 meters. So this is one of the freely available high resolution satellite imagery which you can download for free of cost and you can use for your work. But the one of the thing which we have considered this, so these satellites images are available only for recent years. So when you go for like decadal back studies, then these images are not available because there were no satellites during those days, the Sentinel. So these images will not available, so we cannot use it. So if you want to go for 30 years of temporal data, then Landsat is the best one for that, and we can use it. So as I am going to do the land use land cover for this present year, I have downloaded it. Then I have also performed the land use land cover. So this land use land cover is consist of 4 classes. One is build up, another one is vegetation, third one is water body, fourth one is fallow land. The fallow land is the land which is actually agriculture land but left fallow after the cultivation. So here I can show you the image. Here I can swipe it so you can see the satellite image which is behind my land use land cover. So when I see here, I see that like here the red color indicates the buildings and green color indicates the vegetation and blue color indicates the water body and light green color represents fallow land. So this is my result which is on top of the satellite imagery. So when I swipe it, you can see like buildings are falling on the building and vegetations are falling on the vegetation and fallow land is falling on fallow land. And here I have water body. Even if I swipe here, you can see the water body exactly falls on water body. Am I clear to you? Do you follow me? Right. So when I have classified, I didn't get the result what we see here. There were lots of noises were there. Noises were lots of settlements here and there were there. Actually, most of the settlements were fall on the fallow land because the fallow land as well as the building were having the same reflected pixel values. Due to that, I had lots of noises of buildings on the fallow land that I have corrected manually. So still I have some of the errors in it. You can see I can show you. See, here we have the building pixel, right? But actually, if you see here, it is not a building, right? So it's like kind of fallow land, or even I cannot identify exactly whether it's a fallow land or kind of building because my satellite imagery does not support me to identify the feature in this level. So here also I can see some pixels, but I could not understand whether it's really a building or a fallow land, right? So in this case, like we have to go for error matrix, in which we will compare our result with the ground truth, right? So to do that, what we have to do, we have to take some samples on the imageries here and we will go to the field to the same location to identify what we have classified here is correct or not in the real world, right? So before that, I would like to have show you some of the information about it. Is my slide visible to you?
Yes.
Yes, thank you. Right. So,
Yes, sir. Visible.
yeah, thank you so much. Right. First, we take the satellite imagery. We perform some kind of image classification. Once we have done the image classification, we get the result. After getting the result, we will assess accuracy assessment, in which we will get to know whether the classification accuracy is in the acceptable level. So we would never end up with 100% accuracy in real scenario. We will end up with like kind of 75% accuracy, 80% accuracy, or 90 or 95, even 96, 97 we may go, but we never ever end up with 100%. It's not possible in real work, right? But there are some percentage of accuracy is acceptable by scientific community. If your accuracy is within that acceptable percentage, then you can start to interpret your result. So if your accuracy is not within that acceptable limit, if it is lesser than that, then we have to modify our scheme, which is that land use land cover classification, the category we have created, or we have to increase the number of samples what we have taken for the classification, or we have to concentrate more on the recoding the result to make it little more accurate. So we will ask whether it is an acceptable level. If it is yes, then we will interpret the result and we will provide the result to the user who actually need it, or else like we will modify the schema, increase the number of samples to increase the accuracy, or else we do recoding to increase the accuracy of it. Then again we will go for this accuracy assessment, right? So when we want to do the accuracy assessment, first we should determine the sampling techniques. So there are different kind of sampling techniques are there, which is the random sampling or the stratified random sampling or stratified sampling. So among these, which we are going to consider to pick the location or the points or the pixels from the satellite imagery. So among the available, we have to fix it. Then we have to select the pixels or the location as a sample. Then that sample has to be compared with the real world. So for example, you may have classified as a water body in your result. When you compare with the real world, whether it is a water body or not, if it is water body on the ground, then it is a true classification. If it is somebody else, then it is a wrong classification, right? Then we will compute the error matrix. Right. So here what we say, random sampling. So random sampling, all these points what we create on the result what we get here, right? Or else you can go to the ground, you can collect the random sampling, then you can compare with your result. In today's lecture, I'm going to show you how to create the sampling on the result, then how it can be compared with the real world, right? Or systematic sampling. Systematic sampling means the sample which has a specific distance from one sample to another sample to cover the entire area of your study. And stratified sampling means like you will assign the number of samples for each class. For example, I have the build-up and I have the vegetation, I have the water body and fallow land. So I can say how many points of sample I need for water body and how many points of sample I need for vegetation, or how many points of sample I need for fallow land. So I will specify the number of sample for each classes, then I can generate it for the comparison with real world. Right. So why we do all this thing? Like we want to confirm our accuracy. So when you collect your points, so it should be unbiased. Sometimes you may pick the point which is may give you confusion whether it is a forest land or whether it is a agriculture land, or it may give you a confusion whether it is a building or whether it is a fallow land. So in that case, like when you have a confusion on the ground itself, right? So that points should be avoided when you collect the points on the grounds, right? It should be unbiased. Sampling location must be perfect enough to find on the ground, and sample location should be spread over the classified areas. For example, when you have the land like this, right? And when you have a classification result like this, we should not concentrate on a specific place. I should not take the points only on the settlements in this area by avoiding all these areas. So if you do like that, then our accuracy assessment will not be right. So our points should be spread everywhere or evenly entire area, and the influence should be in all the areas. So do not concentrate on a single area place. Right. So here what you see is called as a error matrix. Sometimes it is called as a confusion matrix. This is also called as a contingency matrix. So this is the matrix which tells us what is the percentage of our accuracy. So for example, here I have taken 26 samples. See here I have the satellite imagery. So in these 26 points I have taken for build up, and it is compared with the ground. So when I have taken 20, like for example, I can take it here for you, right? Right. So here I have the location. So this, if I take this location, copy coordinates, this location, here in my result it is build up. I want to compare with the real world. I use this Google Earth to know what is it really. So in ground or in high resolution imagery, when I see it, what feature it is? Can anybody suggest me? Is it right classification or wrong classification? See here I have my result. I collect the location of this place by copying coordinates. I got the latitude longitude of this place and I am pasting in Google Earth, so I can identify exactly what is on the ground. This is a high resolution satellite imagery in which even I can identify individual buildings. So when I search it here, the point falls here saying that, so this location in my result is this on the high resolution imagery. Is my classification this place is right or wrong?
Yes, sir. It is built up.
It is correct, sir.
So this is correct, right?
Yes.
Yes, sir.
So in the same way, I have collected 26 places or 26 pixel values, and I have compared with the real ground or with the high resolution satellite imagery. So when I have compared it, I found 23 points are falling on the ground correctly, right? So I can show you some kind of errors, like here I have one point. This is saying it is a build-up, right? I take the location of it, then I paste it in Google Earth, so which is a high resolution image. This is the location. Do I have the building here?
No,
Is it
there
right
is no.
classification? This is right or wrong?
Wrong
Wrong.
classification.
This is wrong because in my image I have classified as a build up, but in real world it falls on fallow land, right? So this is the wrong class here. In the same like that, I have taken totally 26. Among the 26, 23 points are true on the ground, but 3 points fall on the fallow. Am I clear?
Yes, sir.
So here I have compared for the build up, then 24 points I have collected for vegetation. When I compare with the ground, 22 points are correct on the ground. Whatever I have classified in the my result as a vegetation matches with the ground. But 2 points are wrong. One is falls on the fallow land, other one is falling on the water body. Am I clear? Guys, am I clear?
Clear, sir.
Right. So in the same way, I have taken the fallow 24 points, and when I compare with the real world, only 21 was right, and there is a mistake of one vegetation and two build up. So in my classification, one fallow land shown in a vegetation, two fallow land shown in a buildup, right? So in the same manner, I have taken 25 samples for water body, 24 are real on the ground, one is falling on the vegetation, right? So totally my samples are 29, which is consist of 26 for buildup, 24 for vegetation, 24 for fallow, and 25 for water body. So in this 99, if I say the right pixels or which matches exactly on my classification result and ground is this diagonal pixel values. 23 build up, 22 vegetation, 21 fallow land, and 24 water bodies are matching with my result on the ground. So these are all the correct pixels, right? So when you take these values, correct pixel values, and divided by total number of pixel you have taken, you will get the overall accuracy. So the problem with overall accuracy is you will identify what much or what percentage of accuracy you get, but it does not provide buildup may have be classified 99 percentage, and vegetation may have classified into 50 percentage, and fallow may be classified into 60 percentage. But these different classes accuracy we will not get. To get these different classes accuracy, we will use user accuracy and producer accuracy, right? So the number of classes, like number of correctly classified pixels in each class divided by total number of classes is user accuracy. So here we have the user accuracy of buildup is 88.46 and vegetation 91.67 and fallow is 87.50 and water body is 96.0, right? So this is a user accuracy. This accuracy from the point of the users, those who are going to use your classification result, right? So the another one is producer accuracy. This producer accuracy is the point from the point of the person who has developed or who has done the work of land use land cover, right? So this is calculated based on number of correct locations on the ground as well as on our satellite imagery result divided by total number of places in build-up, right? So 23 divided by 25, we will end up with 92. So there is another class also which is called as a commission and emission errors. What is this commission errors means? So actually, when I taken the build-up, I have taken 26, right? In this 26, only 23 is the right pixel. the 3 pixel which is belongs to fallow land, I have classified as a build up in my result, right? Which is commission. I have included 3 pixels wrongly in my build up. So this is included, right? So the included values wrongly is called as a commission errors. Whereas omission error means the real build-up values which I have missed to the other classes. If you see here, so here 2 build-up locations in real world is classified as fallow land in my imagery. So this is a error done by the producer. So when you take these values as a error, then we say it is a omission, which is 2 divided by 25. So 8% of error in build-up for producer, and here we have 11.54 is a commission added land use or land cover to the build-up. Here user accuracy is the accuracy from the point of users. Producer accuracy is from the point of the person who has produced the result. And the commission error means how much other land use land cover is classified wrongly as build-up. See here I have 26. In this 26 location, which is actually what I thought is a build-up. But 3 location in real world it is fallow. The extra 3 which is belongs to another class is added as a build-up. So which is called as a commission, which we have included wrongly. Whereas omission means which is actually a build-up in a real world, but we have classified this wrongly. See, these 2 fallow land in real world I have classified as build-up. So this is called as a omission, which we have left it to the other classes. Am I clear?
Yes, sir.
Yes. So
Yes, sir.
if you add the omission error with the producer accuracy, you will end up with 100%. So my producer accuracy is 92%. I have the error of 8%, which is a omission error. So here if you see the user's accuracy is 88.46, the error of user accuracy is considered as commission error, which is 11.54. So if you add these two, we will get 100%. Okay. Okay, how much percentage of accuracy is required if you are proving any hypothesis, right? How many training samples required for classification for any class? My study area is 450 kilometer square. Okay, this is the question what actually I need from the participants. We have the answer for these two questions. So over the time when the classes move on, you will understand it. Right. Right, the total accuracy is a general accuracy of our overall land use land cover classification, which does not provide the class-wise accuracy, right? That is the calculating the number of pixels in all the classes divided by total number of classes we have taken. In our case, 23 plus 22 plus 21 plus 24 divided by 99, which provides the overall accuracy of 90.91. So that is the here. So as I said, total accuracy is calculated number of correct samples divided by total number of samples. So this total accuracy result an average. It does not reveal if error was evenly distributed between the classes or if some classes were really bad and some really good. So as we do not have the answer here for each classes, then we will come to user accuracy and producer accuracy to show the accuracy at the class level, right? So what is user accuracy? The user accuracy correspond to the error of commission, which is inclusion. For example, build-up side included wrongly in the vegetation category. So when you have the vegetation category in your result, in that you have added build-up area also as a vegetation. You have included other classes wrongly in a vegetation. All right. So whereas producer accuracy correspond to the error of omission, which is exclusion. For when you do a vegetation, you leave some vegetation area wrongly to other classes. So vegetation site omitted from its category. Right. So user accuracy from the perspective of the user of the classified map, how accurate the map is. For a given class, how many of the pixels on the map are actually what they are, what they say they are, right? So it is calculated number of correctly identified in a given map class divided by number of claimed to be that map. Whereas producer accuracy is from the perspective of the maker of the classified map, how accurate is the map. For given class in reference place, how many of the pixels on the map are labeled correctly when this producer has produced this image or the land use land cover result. So it is calculated by number of correctly identified in reference place of a given class divided by number of actually in the reference class. Right. Then we come to the kappa coefficient. So once see this error matrix itself provides as user accuracy and commission error, producer accuracy, omission error, and overall accuracy. So after that, we prove our accuracy with statistically using kappa coefficient. So this is a kappa coefficient formula in which number of samples into sum of diagonal values minus sum of each classes rows total and column totals divided by total number of samples with the power of 2 minus sum of each category's column total with row total. So here I have calculated the kappa value for the table what I have prepared here. So this table is the input for kappa coefficient. If you do not have this table with the overall accuracy calculation, you may not perform kappa coefficient, right? So this table's value is inserted here. So here n is number of samples. We have taken 99 number of samples, total samples, in which sum of xii, which is the correctly classified pixels, which is the total of 90, then minus sum of a particular class row total and column total. So here if you see this 26 is the build up row total and 25 is the column total. In the same way I have added here for vegetation, fallow land and water bodies. So when you use these data in this formula, then you will end up with this value, then this will become this. Then when you calculate, you will end up with the value of 0.878. Always these kappa's values will be lesser than overall accuracy when you convert this kappa into percentage. Here we get the, if you see the actual value which is 0.878, if you convert this into percentage, which is almost 89%. Right. So here we have the interpretation for kappa. The result of kappa tells us whether the satellite imagery classification as well as ground truth is having the good agreement or not. That means whether it is same or not. If it is same, in which level these are similar, right? So if the value is lesser than 0, it says there is no agreement at all. So our classification is worst. It does not match with the real world. So if it is 0 to 0.2, then its slight agreement is there, which means slightly it is matching with the real world. So whereas the value of like 0.81 to 2, it is almost perfect agreement. That means it is almost perfectly matching with the real world. So what we get is here is 0.878, which falls in this category. So our result is almost perfect agreement when we compare with the real world. Am I clear?
Yes, sir.
Right. Now we will go to the demonstration. If everything is clear, then I will move on, because further what I am going to do is everything is automated. So we may not see how it is calculated. We will get only the result. Is everything clear?
So I had a question.
Yes.
So for real world comparison, the software is comparing it with the Google Earth's image, or how is it
Right.
like, or
So
are we?
yes, yes, yes. See, software has the tool to manipulate the values what we provide. Generally, we human collect the location from the land use land cover result. Then we go to the ground with the GPS. Uh, with the like, I will show you it here. This would be much easier. Right. So, do you see my map here? Do you see my map?
Yes, sir.
Right. So how many number of sample is necessary, right? So there is no rule. Here I can say this is the research paper like I referred here. Therefore, you can read this paper. I can share you with Sardar later. You can take it from him. The practical consideration more often dictate the sample size selection. A balance between what is statistically sound and what is practically attainable must be found. It has been my experience, the author's experience, that a good rule of thumb seems to be collecting a minimum of 50 samples for each vegetation or land use category in the error matrix. So he says that like when you come with the statistical analysis, like you may get like 3,000 pixels or 5,000 pixels or 10,000 pixels, which may not be possible in the practical to go and collect the information and compare it. So there are lots of paper in which they have mentioned at least you go with 50 points for each category. If the area is especially large, which is more than million acres, or the classification has large number of vegetation or land use categories, which is more than 12 categories, the minimum number of samples should be increased to 75 to 100 samples per category. Because you collect the location from your result and you go to the ground to identify whether it is correct or wrong. So when you have more number of samples, then practically it may not be possible to correlate your result with the real world, and it may be possible, but it may take longer time period, which may not be sufficient for us to produce the result. So that's why they say 50 at least we should take it. If it is larger area or the larger classification, you can go with 75 to 100. Am I clear to you for this question?
Yes, sir. And for the sample collection, which technique should we consider or most suitable, or it varies from place to place or
Yes.
region
Right.
to region?
Right. So that we will see now. Now I have 1, 2, 3, 4. Right? We have 4 categories. I would like to go for 40 samples because as per the rule we have to go 50 for each classes, but now I do not want to take more number of classes, so I want to prove whether accuracy is acceptable or not. When you have more number of points, then it takes longer time. So I will go with 10 for this demonstration, but when you do real, you can go with 50 samples, right? So here we have a tool which will help us to create the random sampling. Most of this image analysis software may have it, right? So here we have create accurate assessment points. And as in last class, when I have explained to you this, I said these pixels are having the values, even though we see buildup, vegetation, water body, and fallow land here. So in software, in the tools, it considers the pixel values. With the pixel value means value class 1, 2, 3, 4, right? Value 1 represented buildup, value 2 represented vegetation, value 3 represented water body, value 4 represented fallow land, right? So you just keep in your mind this pixel, these value classes which represented the different land use land cover here, right? So now I'm going to create accuracy assessment point. Then input raster or feature class. This is my result. This result I am giving here, which is classified this image. All right. Then it asks where you want to save your result or the output points which you are going to use for your accuracy assessment. So I save in my folder in the name of sample location. It should be saved as save file here. I saved it. And the target field in whether you are going to create the classified field from the land use land cover imagery or you are going to get ground truth data. I'm not going to get the ground truth now. I'm going to get the classified values from this image. Then here we have the sample method. Whether you want stratified random sampling or Euclid stratified random sampling or random sampling. So random sampling means it number of points what you say here randomly. When you say stratified random, then it will create for each class specific point randomly. But if you say equalize stratified random, it will create equal number of samples for each classes. So for example, if I say random and if I give I need 40, irrespective of classes, it will create 40 samples on any classes. Sometimes some classes may have higher number of points and some classes will have less number of points. And if I say equalize stratify random, each class will have the equal number. In this case, builder will have 10, vegetation may have 10, fallow land will have 10. And if you say stratified random, and each class will have 40 classes here. So I go with equalized stratify random. I give total number of random points are 40. I say run it. Here you can see the file name, sample location, and I go to attribute table. Totally we have 40 pixel points here, and if I make it ascending, see 10 point for value 1 classified. So value 1 what we have seen here, it is a build up. So we have 10 points for build up. Value 2 which indicates the vegetation. We have 10 points here for vegetation. For each class I have 10 points, right? I will say this satisfied random. What would happen when I will change this value 1? Right. Now what would happen when I say simple satisfy random, based on the area of our each class, number of points will be generated. Larger the area will have more number of samples, smaller the area will have less number of samples. Now I go with normal stratified random. Okay. In this case, we have fallow land is a larger area here. I descend it here. Fallow land value is 4. If you see, we have 14 point for fallow land. The least area what we have is water body, which is the value number 3. We have 10 samples for water body. Am I clear what I am trying to say?
Yes, sir.
Somebody asked the question, what is the difference between stratified random or what is random? So stratified random takes the total number and it's distributed higher number of samples for larger area, less number of samples for smaller area. Whereas this equalized stratified random provides equal number of samples for each classes. Random does not consider any classes. It considers our spatial extension of our image. Then it provides randomly. Am I clear?
Yes, sir. But which technique is most suitable for
That's also there is no
thumbnail?
conformed techniques are there. Whichever you feel suitable, or you use one technique, if doesn't work well, then you can go for another one. So you can go for this stratified random. If there is any appropriate technique, then we may not have more statistical techniques here. So that's why it may work. Some places it may work well, some places it may not work well. So you can go with first stratified random, or equalized stratified random, or random one by one, which provides the more result for you. You can go with, or else like the default one always what they give works well, which is a stratified random.
Okay, sir.
Right. Okay, I will go with this 40 point, which has the equal value for each classes. 40. So here value 1 represents build up. So this is the pixel, that this pixel, which is actually a build up with the value of 1. So if I enter value 1, which is the ground truth here, which means it is correctly classified. Or else in the land, if it is something else, then I will put whether it is a vegetation or water body here. Am I clear? If I am clear to you, I will move on further.
Yes, sir.
Right.
So after ground verification, we have to change the value to 1, or
Now I will do it. You just follow me. So your answer for your question is here. Right. So when I have done for my work, because I also have done land use land cover. So when I have done during those days, and these tools were not available, everything we have done manually, even there were no high resolution imagery was not available. So everything we have done manually, like I went to field with the GPS, and I have seen what land cover or land use present there. So in if you want to do like this, what you can do, all these sample locations, in our case it is 40. So these values can be exported or converted into the GPS file format, which is GPX file format. Then it can be downloaded into GPS. Then that location you can travel, go to the place and see the place by yourself. And if it is land matches with your class result, then you confirm it is right. So if it is different on the ground, then you say it is wrong, right? But now we have high resolution imageries, so in which even you can, like, I can see the individual trees here. In this case, it is not necessary to go to the ground to see whether it is a water body, whether it is a building, or whether it is a vegetation, because here itself we have the information. But we should make sure one thing, that this classification result what we have here should match us with the imagery. For example, if you do this for 2023 imagery, and if this imagery is belongs to 1980, then you will end up with error. So the same year, even when you go for vegetation and all, it should be the same date or same month or same season is best if you use these satellite imageries, high resolution satellite imageries, or aerial photograph as your reference data. If you do not have high resolution imagery for the exact date or the month, or where there is no much changes, in that case you have to go to the ground with the GPS. Am I clear?
got it, sir. Thank you.
Right. So here I have my result, as well as I have the land use land cover. I have here, they are providing world high resolution imagery. Here in R Pro, we get the base map in which we can get the satellite imagery in high resolution, right? We do not want to go to Google Earth to see it as a base map background image. We can add it here itself, right? So here I have a table in which I have to enter whether it is a right or wrong. So all the 1 in this classify field indicates a build-up, and 2 indicates the vegetation, 3 indicates the water body, 4 indicates the fallow land, right? So I can make it symbology also for our understanding. For unique value, we will go with yes classified. Right. Here we have the different symbol. In which red color locations represented build-up in our classification, green represented vegetation, blue represented water body, and this light green represented fallow land. So I will go and check whether it is falling correctly here. Is it right or wrong? Is this right or wrong? Please tell me, is it building?
Wrong, sir.
It's wrong. So actually where it is falling? I think it's a kind of construction, like this kind of things. When you do not have idea, it's better to go to field to identify what it is. I think it's a kind of material what they have used to construct it, and how it is in our result. No, it's Italy. Okay, so we consider this, it is wrongly classified. So which one? This one is I selected, right? Or else I will go one by one here. So this is best for us. I pan to here. Is this building? Yes, then it's right. Value 1. Building, right? Then I will move on to the next one. Is this building? Yes, it's building, right? Correct. Then is this building? It's not building, but it's a fallow land, right? In our case, it's fallow land, which is value of 4. Then I go to here. This is fallow land. It's not a building. And keeps because I am checking this satellite imagery, right? And you should confirm that the satellite imagery which you have here as a base should have the same data of the image what you have classified. If you have the satellite imagery which is 1 year old, then you will end up with error. So that's why you make sure that the reference data is same date or at least a week or month of your result. Right. So this is the building. Yes, it falls on the road. Then it's right. Value 1. It's a vegetation. It's not a building, right? It's a vegetation, and which is vegetation. In our case, it's the value 2. Then here, if you see, it's a agriculture land, right? Which is in our case vegetation, which is a value 2. If you see here, it's built up correctly. We have classified. It's a built up area, so it's a value 1. Then this one is building. Yes, it's falling on the building areas, so value 1. Then this is it falls here. I think it's a kind of structure, the building structure what they made here. Right, we will, what shall we do? Shall we consider as a right or wrong? Anybody?
Yes, sir.
Okay, we consider this as right in our sample. Then value 2, now we are moving to the vegetation areas. Yes, it's a vegetation. Value 2, yes. Yes, it's a vegetation. Value 2. Yes, it's vegetation, value 2. Like I will move on like this fastly. So here it's a fallow land or it falls on the vegetation. Okay, correct. It's fallow land. Okay, I consider this as a wrong classification, which is fallow land. In our case, the value 4. Okay, vegetation near the water body. Okay, now I am in the class 3, which belongs to water body. This problem you just see in our satellite imagery, the boundary of water is here, the shore is here, but our location is here, so which we have classified as a water body. So these water bodies are dynamic in nature. Even every day the shoreline get changes due to higher temperature, it may get evaporate, or if there is a rainfall, then the amount of water will get increases and the boundary will get change. So if there is any damn difference between your satellite imagery and your reference data, then we may not get correct idea. Here it says here, as we have considered as a water body, in this satellite imagery water is here, right? So I consider this as fallow land, which is a value of 4. So by considering this satellite imagery is the same data of the image what I have used here, this one, what I have used here, right? You can see here. In this, water is still this, but in this, the water is still here, all right? So when it comes to the different date, we will end up with this kind of problem. In this case, I consider this as a fallow, which is actually not in our satellite imagery. For this demonstration, I'm considering this as a not water body. See, this is water body, which is a value of 3. This is water body value of 3. This is water body value of 3. 3, 3. Water body. It's not water body, it's a kind of agricultural land, or not agriculture, kind of grass or something here. So I make it as 2, which is vegetation. Then this is not, it's a water body. It's a water body. 3, 4. We come to 4, which is a fallow land, but actually it falls on vegetation, so I say it is value 2. Then this is fallow land value 4. This is fallow land value 4. Fallow land. Yes, fallow land. Yes, fallow land. Falls on the fallow land. Yes, fallow. 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 Am I clear? I have given for all the points, 40 points. Am I clear to you? Guys, am I online?
Yes, sir, it's clear.
Okay. So this is the value which we have taken from our classified image, and here I have the ground truth. See, when you go for ground truth, make sure that you are going to the exact location, and if you use this high resolution imagery, that should be the same data of the image what you have used for low resolution imagery. Am I clear? Right.
Yes.
So now I have the point in which I have a ground truth data which I have taken from the high resolution imagery, as well as the land use land cover values which I have extracted. Right. Now we will perform accuracy assessment. Compute confusion matrix. The input data is sample, location. Then I need the matrix here in the name of error matrix. I click on save. I think I may have the same file there, so I make error matrix 1, or the file size should not be more than 10. Okay, it should be a DBF file, sorry. I say error matrix dot DBF. So this should be saved as a DBF file, database file, right? I run it. So it is completed. The file is here, which is added. If I open it, you can see the table what I showed you in the PowerPoint. So here the minimum value is between 0 to 1 in our classification. So 1 means 100. Here if you see C1, in our case C class 1 is build up, class 2 is a vegetation, class 3 is water body, class 4 is fallow land, right? So the same thing what we have here. We got the result here, and we have a number of accurate pixel for water body as well as fallow land for vegetation and build up, right? So here we have user accuracy, here we have producer accuracy, and we also have kappa coefficient answer, which is 0.73. So the overall accuracy is 0.8, which indicates that our overall accuracy is 80%. Am I clear?
Yes.
Right. So this table, what we have discussed in the PowerPoint, have done here manually after entering the true values in the sample location data. So this is way how we can perform in ARC Pro. The same it is available in IRDA as well as ArcGIS desktop. Even in QGIS, there are some tools which will help you to produce this statistical. Right. So now the matter is how many samples we have decided already, because there is no perfect rule, but we have a kind of experienced rule of 50 per classes, right? Now the question is how much percentage of accuracy is acceptable. So one guy may come up with the percentage of 75, other guy may come up with the percentage of 95, other may come with the 60, right? So should you want to consider all the three as a acceptable accuracy, or one should be acceptable and other should be rejected, or other should be given more work to increase the accuracy? So we have an answer for that from some standard given by international as well as by Government of India, right? So this is the land use land cover classification category given by the group of committee under the head of this James R. Anderson. So they have published this article long back after the successful data collected by Landsat 1. So they have done in 1976 after they have started to use the Landsat 1 satellite imageries, in which they say the minimum level of interpretation accuracy in the identification of land use land cover categories from remote sensor data should be at least 85%. So if you have proved your classification accuracy is 85% or more than that, then you can straight away go for interpret your result and provide to the user. Or if it is less than 85, then you have to increase the number of classification samples, which is the training site, or you have to spend more time to recode your result and do all the process once again to increase the accuracy to make over to more than 85%. Am I clear?
Yes.
Someone has asked this
Yes.
question. Yes, right. So if you send some paper only with the result of land use land cover without this error matrix and kappa coefficient, without proving your accuracy is more than or equal to 85%, then they will not accept it, right? So these are all the criteria they have given for by using the Landsat 1, right? Then the second one is they said the accuracy of interpretation for the several categories should be about to equal. That means like in our case, we have used 4 classes, and if you see these 4 classes accuracy, at least it should be about to equal. See here we have the user accuracy 0.6, 0.9, 0.8, 0.9, and here if you see it is 0.1 we have here for build up, 0.6, and 1 we have for this third class which is water body, and 0.69. So they say that each class's accuracy should be about to equal, right? And repeatable or repetitive results should be obtained from one interpreter to another and from one time to another should be same. For example, if I use this satellite imagery in my system and produce it, and this result should be at least matches with the people, those who are doing in the different systems, right? And as well as if I do this today and if I do it next year, and the result should be at least match with one another, right? And the classification system should be applicable over extensive areas. See, here we have taken 4 classes, right? So these 4 classes should be generalized when you want to go for larger area. Now I have done for the small area. So if you increase the classification system for the larger area, then this classification system should be used. So sometime like the one class what we use here may not be used when you enlarge the area. So it's not be like that. The categorization should permit vegetation and other types of land cover to be used as a surrogates for the activities, right? So when you have the vegetation or other land covers, then when you want to go for this some other classes as this, then it should be eligible to make it. The classification system should be suitable for the use with remote sensor data obtained at different time intervals or different time periods. So like here we have 4 classes now, and the future if you get any other satellite imagery, for that this classification system should be applicable. Then effective use of subcategories that can be obtained from ground surveys or from the use of larger scale or enhanced remote sensor data should be possible. Aggregation of categories must be possible. Comparison with future land use data should be possible. Manipulate uses of land should be recognized when it is possible. So these criteria they have given. So when you make the classes here, like now I have built up, or when you go for next level classification, this build up can be divided into 2, saying that residential and commercial. Or still if you want to go for further, then it can be commercial, can be industries, or it can be shops, right? And still if you want to go further, then we can say multi-story building, single story building, or huts. So if you want to go for these classes, then we have to use high resolution satellite imagery. It is not possible with this sentinel data, right? So that is the classification system what we have here. It should be applicable for larger area, and this system should be applicable for different time periods. Like you may have this classification system now which may not be useful for after 10 years, means then the work what we have done today will not be used after 10 years. That's why they say, so this system should be common, and it should be also valuable to use even in the future. So this is given by Anderson and his team, and we will see what our criteria says. So this is based on IRS 1A application for land use land cover mapping in India. So here we have our local criteria in which they say the land use land cover classification system involved should be applicable over larger area. So that means you make a classification system like which has like land, building, or vegetation, water body, fallow land, then barren land, salt affected areas, all these classes what you have do for a area. So that should be also applicable for other places and larger area when you enlarge your classification. The classification system should be suitable for using satellite data obtained at different period of the year. So if you have month-wise satellite imagery, and all these imageries should be classified evenly with the same classes. So then only like if in the future if they want to do any kind of comparison study using this result, and it is possible. And you use only 3 classes for 1 month and 5 classes for next month and 10 classes for the third month, then we cannot do any comparison study using our result, right? assemblage of land use land cover categories must be possible. Like if you have 2 to 3 category and if you want to join together, that should be possible. The minimum interpretation accuracy and reliability in identification of land use land cover category from satellite data should be at least 85 to 95 percentage. So the Anderson classification criteria, they said at least 85. So in our Indian classification, they say at least 85 to 95 percentage it should be. Right. Due to the small scale of satellite imagery, certain land use land cover categories may be generalized. For example, different agricultural crops can be put together under the main category of agriculture. So that's why they say that, like, when you use core or poor spatial resolution satellite imagery, so it is not possible to differentiate between the whether it is a forest or whether it is agricultural land, whether it is grass. In that case, all these things can be put together in the name of vegetation. In this case here, what they say is, like, when you cannot identify or when you cannot differentiate the crops, then this area can be put together as a agriculture. Choice of data should be planned on the basis of the dominant use of the map is intended to serve and the levels of details needed. For most purpose, imagery obtained in Kharif and Rabi seasons would be ideal for land use mapping. So if you want to do land use mapping, like the time period when the Kharif and Rabi is grown, so that would be best, because you have the crops on the agricultural land, that classes can be done clearly. To decide on an appropriate classification or the classification level within a classification, an appropriate decision must be made. One must decide on the imagery scale or on the scale of the representation of the data. Data based on scales of 1 is to 1 million or 1 is to 2 lakh, 25 lakh, no, 2 lakh 50,000 or 1 is to 50,000 should serve the 3 levels, mainly level 1, level 2, level 3 classification, right? That means based on the class what you have, no, no, sorry, based on the spatial resolution of the satellite imagery, you can go for whether you are going for level 1 class or level 2 class or level 3 class, right? Guys, am I clear?
Yes, sir.
Should I want to repeat anything, or you do have any kind of query would you like to ask now? Right, then I will move on. Guys, can anyone tell me what is the difference between land use and land cover? I think today is almost the last session.
Land use is artificial usage of land, sir, by human beings and settlement. And land cover is a naturally available, which is like forest, water body.
Okay, is build up is land use or land cover?
Land
Buildings.
use,
Buildings?
land use, land use.
Is there anybody else can say buildings or land use or land cover? So one answer is land use. Is there anybody else? Or land use? One more answer also has come, land use.
Yes, sir. Land cover is what covers the surface of the earth, and land use describes how the land is used.
Okay, build
So,
up comes under which category?
built up covers under land cover. Land use. See, land cover classes include water, snow, grassland, and forest, and land use include wildlife, agriculture, and urban.
Okay. The build up is land cover. For what purpose the building is used is land use. For example, we have the buildings, right?
Okay.
Buildings will be land cover. Residence is the land use. Okay, that's why, because most of them may misunderstood the building is the land use. Building is the not land use, it is a land cover. And the purpose the building used is land use. So that's why I asked it. I can give you the definition of it correctly. Right.
Okay, but from the previous lectures I have attended, the faculty which are from NRSC, they told us that these definitions, sir.
Okay.
But fine, I
Right.
have cleared. Yeah, thank
Okay.
you.
So here, one concept that has much merit is that land use refers to man's activities on land which are directly related to the land. Man's activity which are directly related to land.
Yeah, it means
Land cover, on the other hand, describes the vegetational and artificial constructions covering the land surface. So building is an artificial construction. Roads are artificial constructions.
okay. It
These are
means simply
land covers,
land use describes the use of um
buildings
yeah, the use of
for
land by people for different activities like such like recreation, housing, agriculture, and educational purpose. Am I right?
yes. See, I can say this for golf ground. That is like we may not have here, but in the developed country they have this.
Yeah.
We may say it is a grassland.
Yes.
Land cover is grassland. Golf is the golf. I do not know exactly how to say that. The golf they play, right. The
Yes.
game golf they play, right.
Hmm.
That is the land use, recreational
Yes.
land use.
Yes.
But
Yes.
land
Golf
cover
is
is
the hmm.
grassland.
Yes. Golf is the example of land use. Yes.
Yes.
Thank you, sir.
Beach, like so buildings are or the any constructions are land use. The like what the building is used for is land use. When it comes to the land cover, we consider any artificial construction on the ground. Okay. Right. So right. So when we have coarse resolution satellite imagery, which we can classify or which level we can go. So when you have the satellite imagery which is having 30 meter of resolution, then we can go up to the level of 1. Or if you have the high altitude data which is like 12 kilometer or above, we have to go with level 2 classification with the scale of less than 1 is 80,000, right? Or if you have little higher resolution in the medium altitude, which is between 10,000 to 40,000 feet or approximately 3 kilometer to 12 kilometer, then we can go for level 3 with scale, having the scale of 1 is to 20,000 or 1 is to between 1 is to 80,000 scale. Still, if you increase the spatial resolution of satellite imagery using low altitude sensors, which is taken in below than 3 kilometer, then we can go with the scale, or we can create the fourth classification with the scale of 1 is to 20,000, right? And nowadays we have the drone. So if you take the images using drone, then easily you can go for class 4 classification. So what is this level 1, level 2, level 3, level 4 classes? Because they say if you use Landsat, you can go for only level 1. If you use high altitude data in this distance, you can go for level 2 or level 3, level 4. That means, so each major classes are subdivided in second class. And these second level classes are again subdivided and more informations are extracted from the satellite imageries. When it go from third to fourth, more information of this first category is extracted. That we will see here. So here we have level 1 and level 2 class. See here I have given only builder, right? So I didn't say whether these build-ups are belongs to residential or whether it is belongs to commercial or whether it is belongs to educational purpose or government buildings. Here we have only build-up. In that case I can say I have considered the level 1 classification here, build-up, right? But when you have a build-up and in the build-up itself you can make it whether it's a residential building or whether it is a commercial or service building or industrial building or it is belongs to transportation communication utilities and industrial and commercial complex, then you should have high resolution data than the level 1. Then only you can find out this, then you can make level 2. So instead of having only built up here, we will have the classes which comes in the level 2, right? Still, if you have high resolution imagery, then this residential can be again divided into several subclasses to get more information, right? So here buildup is classified into 1, 2, 3, 4, 5, 6, 7 subcategories. Then when it is coarse resolution, we can say agriculture land. And when you have little higher resolution, then it can go to the next category saying cropland and pasture and orchard groves, vineyards, nurseries, and ornamental horticulture areas or confined feeding operations or other agriculture land, right? So here, if you see here in level 1, as per this Anderson team, they say level 1 urban and build up, which also having its second level, and still there are third level that we will see later. Then agriculture land, then rangeland, forest land, water, wetland, barren land, then tundra and perennial snow or ice. So this each level 1 category can be subcategories with these categories. Still, if you go have the high resolution, then we can go for third class, right? See here, level 1 is urban or build up. When it having higher resolution, we go for residential. Still, when you have a higher resolution, then we go single family units or multi-family units or group quarters or residential hotels, mobile home park, traditional lodging and others. So these are all how accurately, precisely information is extracted when you have the high resolution data. Am I clear?
Actually, about this second order or third order classification of this built up, it is very difficult, no? Because it is completely demographic pattern. It is coming single family
Just a
or
minute,
two
just a minute,
family.
just a minute. I go to some other, okay. So it's a build-up, right?
Yes, sir.
Can you tell me for what purpose this building might be used?
No,
This.
sir, but my point of view that when we are collecting the signature, actually we are collecting the reflectance.
Ah,
So
ah, ah.
whatever it is,
No, this is
single.
satellite imagery. See, what you see here is a satellite imagery.
Yes,
It's a satellite imagery, right? It's a satellite imagery. So once you have classified these using the supervised and unsupervised classification, even this now there are lots of algorithm has come with the deep learning in which you can identify based on the object. See here you can see the building, right?
sir.
And
Then
this building is
on the
associated with a large space here.
yes, sir.
See, this building is associated with this large space. And if you taken this as an object, then the same kind of the build or same or the a building with a large area of open space will be identified. See, this classification criteria is to classify, but they do not mention which kind of classification this technique you have to use, because we have different techniques. See here, see here we have a big building and here we have lots of spaces. Will it be residential?
No.
It may be a storehouse or
Factory.
factory, it can be, see, here, when I come here, here I have a building, this building. So I cannot say it's an industrial because it does not have the shape and size of the industry, right? Once you have extract the buildings, then by seeing the shape and size of it, then you can say it is a residential or commercial, or it is industry, right? So that's why we say when you go for the high resolution satellite imagery, then only we can find out this.
Then it is the like as a object base. That is, I'm identifying the settlements on the basis of the object. It is maybe the residential area or it is the commercial. But
Yes.
I want to say that when I am pixel based or supervised or unsupervised, I'm going to any of this technique. Actually,
No,
I'm
no. Yeah.
considering the
No,
wavelength.
no.
So wavelength for this residential also commercial for
No,
the built up also same. So how I can differentiate?
no, that, see, once you have classified, to confirm our classification itself, we go to the ground to make it sure, right?
My
So
point
this
of view,
single family unit and multi-family unit, you will not have in the satellite imagery because you will see only the terrace of the building.
yes, sir.
So
Yes.
this information you may get as a ancillary data from the government body who is administrating there.
Okay. Then it is very difficult. So, sir, if it
Ah,
is like that, I'm
mm.
classifying the first order only the built up. When I will move in second order, then I
Yes,
will consider the which are the glass materials made of glass
yes.
materials.
By
So
looking this image, you can
like
say
this.
yes,
Yes, sir. Yes.
yes,
Actually, my point of view this
yes,
that if I consider the agriculture, then all agriculture, wheat, paddy, mustard is agriculture. When
yes.
again I will second order, then I will differentiate in different types of varieties of paddy. In third order,
See
under
here.
of this again
Yeah.
varieties. So I think
See,
this the first one
in
will
Yeah,
about the
I have
subcategories of the built up, I think it is little bit contradictory for me.
see here.
just
This is
just I have
agriculture.
I want to say something on this matter. Yeah, it is also possible third level because I also done land use and land cover mapping regarding the US data, and I also find out the AC unit, and the AC unit is the very small unit of the residential area, and I also mark the AC unit also. So it depending the practice matter, and more and more imagery when you have to try now, then it is possible.
Okay. Thank you for your information. And see, I make a first class, I can say these are all agriculture land. But when I go for the next one, class 2, I can say this is different from this. So it can be kind of some vegetables, and here I can say it is a paddy. So the level 1 is agriculture land, level 2 can be a paddy and vegetable plants. Am I clear?
Yes.
Right. So the image having already information of individual household will help you as ancillary data to add in your land use land cover classification. Am I clear?
Yes.
Yes. Right. Then here, like, if I can share this, there is a big book, and in which they have given this detailed land use land cover classification procedure what we have to follow. And this is for our country levels of classification using satellite data. So this is for this United States, they have given using Landsat. So here we have this Indians classification system, and we also have our own level of classification system, right? See, we have level 1, level 2 classification, and level 3 and level 4 also we can go. So when it goes to the level 4, it is up to the interpreter or the person who is doing classification. Based on his recruitment, he can still go on uh, higher level classification. RSC, right? See here they have mentioned it. The National Land Use Land Cover Classification System for India has been developed under the National Remote Sensing Agency, Department of Space, in consideration of the views of the several user departments, including the Planning Commission of India. The system is fairly compatible with those followed by most of other government departments in the country, right? So we have level 1 and level 2. In level 1 we have build up. In level 2 also we have build up, right? This is using uh, IRS 1A data, right? Right. In level 2, we have agricultural land, and which can be um, deeper classified as cropland in Kharif, Rabi, or Kharif
ओके.
and Rabi,
मला व्हॉट्सअपला
or
पाठवू
fallow
पण टाक,
land
म्हणजे मी
or
पण त्यांना
plantation. Then we have
व्हॉट्सअपला
forest.
पण
The
टाक, कधी
forest
कधी
can be
काही जण मेल
classified
बघत
into
नाहीत.
different subclasses in a level 2, and we have
टाक
wastelands, and which also can be classified into
काळे
various classes. In
तांबेंचं
level 2, we have water bodies and others, right? And these uh, classes are suggested by our
हे नसले तर मी आहे सोडून दे.
Indians
अरे नाही.
category developers, or the criteria developers, as well as American developers using Landsat. But it is not, they have never said it is a strict rule you have to follow everything. It is not a like very defined rules, or very strict rule, because so on the land, like we may not have all these 6 classes in your areas. So some classes may be available, some other classes may not be available. So some classes which is given here may not enough for your local areas when you do the classification. In that case, you can add the class which is not here in yours, right? So here we do not have the snow, right? That's why they have added it with us here, grassland, snow covered, glacier as a second. They have named as others. So if you feel the snow covered area is a major one and you want to make it in the level 1, then you can do that. So there is a kind of decision you can take when you do it. Am I clear to you?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Any comments from your side, or any queries you need, or any supportive information you can provide here for my explanation here? I share these files with Sardar. You
Yes,
can
sir. Please share with me, and I will share to
all the
the
part.
participants in the group.
I hope I have completed my session now, because I have explained
Yes.
how to perform these error matrix, as well as the level of classification based on the spatial resolution of the data what we may get. So if anybody needs any more explanation on any of this what we have discussed, I would like to explain it. Okay, any questions? No, 2 questions there in the chat box for the both I have explained during the time of my lecture. Is there any other question?
David, do you have any other question?
No, sir.
Okay. I
Okay.
think Dr. Mahalingam sir, you have covered very nicely, and session was more interactive.
So this is the
Hence,
thing how
yeah,
I
yeah,
would
yeah,
like to have a session, because otherwise
yeah,
I feel lonely here, like by seeing the computer monitor, I speak continuously.
yeah. And I learned all these things from your student also,
Oh,
and
okay.
all your students praising to you.
Thank you.
Some
Thank you.
students when contacting, and when I say that my friend is working there, they appreciate you,
Thank
appreciate
you.
you.
Thank you. Thank you so much, sir.
So, dear participants, we would like to stop here today's session. Today, Dr. Mahalingam sir has covered both the topics, that is the levels of classification and accuracy assessment. Both the topics are very much important for us, and in future also if you need any help you may please feel free to talk with Mahalingam sir. He may help you, and definitely he is one of the experts in the field of remote sensing and GIS. Uh, on behalf of all the collaborating institutions and on behalf of Internal Quality Assurance Cell Department of Geography and Geoinformatics, my colleagues, dear participants, and on behalf of students, I extend my sincere thanks to Dr. Mahalingam sir. Sir, thank you very much for
Thank
your
you. Thank you.
kind
Thank you so much.
cooperation.
Thank you so much.
Thank you. Thank you.
Thank you.